Okay, these are your notes for Unit 8, Stop 1, Pit Stop A. One-step equations, addition and subtractions. Okay? So if I open this up, what we're going to be doing today is we're going to be solving one-step equations using addition and subtraction. Well, in equations, we like to think of them as scales. Okay, they have to be balanced on both sides. So I've got a little scale here, and what we're going to do on these first two is we're going to draw a visual representation to help us keep our scales balanced. And then we'll go into, after I do the visual, then we'll go into actually following, we'll fill in these steps and then follow those steps to help us solve it algebraically. Okay, so what we're going to be doing is we're going to be figuring out the value of the variable. We're going to be solving for x, or figuring out what x is. So let's start with a visual. I like to call this monster math. So remember that this is a scale, and this is like the tipping point of our scale right here. All right, so whatever's on this side, in order to keep our scale balanced, it has to be the same on this side. Okay, so on this side of my equation, x plus 2 equals 5. I'll rewrite it up here. I've got an x, and I've got a positive 2. So I'm going to draw me two little monsters, and they're positive. So I've got two positive monsters. They kind of look like little Pac-Man guys, but that's just how I draw mine. Okay, so I have x plus two positive monsters. Well, on this side, I got 5 positive monsters. Okay, so I've got x and then 2 positives and 5 positives on this side because I've got an equals 5. So think of this line as like our equal sign. That's our tipping point of our scale. Whatever's on this side of my equation, because equations have equal signs, whatever's on this side of the equation has to balance to whatever's on this side of the equation. They have to be the same. All right, so what we're going to do is we're going to try and figure out what x is. We're going to solve for x. I don't want this variable here anymore. I want to assign it a number. So in order to do that, we are going to try and get this x by itself so that I can figure out what x is. All right, so that means in order to get the x by itself, or that's called isolating the variable. Okay, isolate means to get by itself. If you think of someone's in isolation, that means they are all by themselves. So if I'm going to isolate this x, or get it all by itself, I need to make these two monsters go away, because x is like, hey, leave me alone. I want to be by myself. So these monsters need to go away. Well, if you think back of when we were doing integers, okay, think all the way back to integers, we use what we called 0 pairs, because if I have a 0 pair, which is a positive and a negative, they cancel out. 0 pairs cancel out, because if that was like a positive 1 and a negative 1, if I add those together, okay, 1 plus negative 1, it equals 0. If something equals 0, then it doesn't exist anymore. It can go away. So let's make 0 pairs for these. Well, if I have a positive and a positive, that means I need a negative monster, okay, for each of these positives to cancel them out. Well, remember, this is a scale, and in order to keep it balanced, what I do to one side, I also have to do to the other. So if I added 2 negative monsters over here, then I need to add 2 negative monsters on this side. That way my scale stays balanced. Well, now let's go through and let's cancel out our 0 pairs, because if it's a 0 pair, it equals 0, so it can go away. So on this side, this 0 pair goes away, and on this side, this 0 pair goes away. On this side, here's a 0 pair, that can go away, and here's a 0 pair, so that can go away. So on this side, I'm left with x, and on this side, I'm left with 3 positive monsters. So if these sides are equal, that means that x is going to equal 3 positive monsters, or positive 3. So x should equal positive 3. So that's a visual representation of how we solve a one-step equation. Now what I want to do is I want to go up here to the top and I want to write in our steps on how we're going to solve it algebraically so that we don't have to draw a picture every single time. So our first step is going to be to cut it in half. And when I say cut it in half, I mean to cut the equation in half. So if I had like x plus 1 equals 4, I would want to cut the equation in half, straight down the equal sign, to make sure that whatever I end up doing to this side, I'm also doing to the other side. So step 1 is going to be to cut it in half. So we want to see you draw that line through the equal sign. Okay, step 2 is going to be to isolate the variable. Isolate the variable, and that's an I, sorry. Isolate the variable. And remember, isolate means to get by itself. So we want to get the variable or the letter all by itself. And in order to do that, our third step is going to be to use the inverse. Remember, inverse means opposite. So the inverse operation. So the opposite operation. So the opposite of adding is subtracting. And the opposite of multiplying is dividing. Or vice versa. The opposite of dividing is multiplying. Opposite of subtracting is adding. So we're going to use the inverse or opposite operation to solve. Remember, what you do to one side, you must do to the other. Please do not forget to do this. We have to keep our equation balanced. That's why we drew that line, to help us remember what I do over here, I got to do over here too. So let's go back to number 1. And let's use these steps to solve this equation algebraically and see if it matches what we got up here. So step 1 is to cut it in half. So here's my equal sign. I'm going to cut it straight down the middle in half. Step 2 is to isolate the variable. So let's look here. What is our variable or letter? X. X is our variable. So I want to get X all by itself. So what is bugging X? Well, this plus 2 is bugging X. X is like, hey, plus 2, go away. I need to be by myself. All right? I need to isolate myself. So in order to do that, we're going to use the inverse or opposite operation. So the opposite of adding 2 is subtracting 2. And remember, what you do to one side, you also have to do to the other. So if I subtract 2 over here, I'm going to subtract 2 on this side. These two cancel because 2 minus 2 is 0, and 0 makes that go away. So those cancel, so I'm going to draw a line. All I'm left with now on this side is my x. Okay, my equal sign. And then 5 minus 2, well, that's 3. So I have x equals 3. Well, is that what I got up here? Sure is. Positive 1, 2, and 3. So x equals 3 would be my answer. Now, guys, there is no reason you should ever get any of these problems wrong, because you can always take what you get and plug it back in. So if I said x was 3, if I plug 3 back in instead of x, 3 plus 2 equals 5, it sure does. Okay, so again, you should never get any of these answers wrong, because you can always plug them back in and solve to make sure you did the right thing. So let's do one more example, this time with subtraction, of us drawing the picture, and then we'll just start doing it algebraically, all right, using our steps up here, because that's the way you're going to do it every time. But for you visual people, I want to draw you a picture. All right, so here is our scale. All right, here's our scale. What I have on this side, I need to balance it out with this side. So over here, I've got 4. So I've got positive 4 monsters. Okay, and on this side, I've got an x, and I've got negative 3 monsters. Okay, I've got 3 negative monsters. So I'm going to draw those in purple. Okay, minus 3 or negative 3. So I've got 3 negatives. Now, I need to isolate my variable or get the x by itself. So in order to do that, I need to cancel these out. I need to make these monsters go away. Well, we all know that in order to make a negative go away, we need to give it a positive or create a 0 pair. All right, so for this negative, I'm going to create a positive and a positive and a positive. Okay, and if I do that 3 times, if I add 3 positives over here, I'm going to add 3 positives over here because I got to keep my scale balanced. All right, now these are 0 pairs, so they can cancel out. They can cancel out. So these 0 pairs cancel. There's no 0 pairs on this side to cancel. So that means that all I have left on this side is x. And all I have left on this side is 1, 2, 3, 4, 5, 6, 7 positives. So I have 7 positives on this side. So I'm saying that x is going to equal positive 7. So let's use our steps up here and follow it on this part of the equation. We're going to do it algebraically and see if we get the same answer. All right, so step 1 is to cut it in half. So here's my equal sign. I'm going to cut my equation in half. Step 2 is to isolate the variable. So I want to get this x all by itself. Well, in order to do that, I need to make this minus 3 go away. And we all know that the opposite of subtracting 3 is adding 3. And what I do to one side, I also have to do to the other. Okay, 4 plus 3 is 7. And minus 3 and plus 3 equals 0, so those cancel. So all I have left on this side is x. So x equals 7, that's what I got. That's what I got up here. So it looks like so far we did it right. Let's plug our answer back in. 4 equals, instead of x, I'm going to write 7 minus 3. 7 minus 3 is 4, and 4 equals 4, so I did it right. Okay, let's look at number 3. We're not going to draw any more pictures because it's kind of hard to draw decimals. So let's just follow our rules, our steps, and solve this algebraically. So step 1, cut it in half. Step 2, isolate the variable. So here's my variable, x. I want to get it all by itself. Well, I need to make this plus 4.2 go away. That's bugging the x, and I want to make that go away. So the opposite of adding 4.2 would be subtracting 4.2. What I do to one side, I'm also going to do to the other. These 4.2's cancel because 4.2 minus 4.2 is 0. So all I have left on this side is x. And then 7.3 minus 4.2, I'm going to do that over here just a little bigger. 3 minus 2 is 1. 7 minus 4 is 3. So 3.1. So I say that x equals 3.1. Well, let's plug it back in and make sure. So instead of x, I've got 3.1 plus 4.2 equals 7.3. When you add those together, you get 7.3, and that does equal 7.3, so yes, we did it right. Number 4. Step 1, cut it in half. Step 2, isolate the variable. Here's my variable or my letter. I'm going to get it by itself. So I need to make this minus 3 go away. So the opposite of subtracting 3 is adding 3. What I do to one side, I also have to do to the other. My 3's cancel. So I'm left with x on this side. And 2 plus 3 is 5. So I have x equals 5. Let's plug it back into our equation just to make sure. So instead of x, I'm going to write 5. Minus 3 should equal 2. 5 minus 3 is 2, and 2 does equal 2, so I did it right. Number 5. 4 equals x plus 1. Okay, step 1, cut it in half. Step 2, isolate the variable, so we're going to get x by itself. In order to do that, I'm going to do the inverse operation. So the opposite of adding 1 is subtracting 1. What I do to one side, I'm also going to do to the other. My 1's cancel. 4 minus 1 is 3, and all I have left on this side is x. So I have x equals 3. Let's plug that back in just to make sure. So 4 equals, instead of x, I'm going to write 3 plus 1. So 4 equals 4. Check, I did it right. Number 6. Step 1, cut it in half. Step 2, isolate the variable. So we need to get x by itself. To do that, I'm going to use the inverse operation. So the opposite of subtracting 10 is adding 10. What I do to one side, I will also do to the other. My 10s cancel. I'm left with x on this side, and 4 plus 10 is 14. Let's plug our answer back in to make sure we did it right. 14 minus 10 should equal 4. 14 minus 10 is 4, and 4 does equal 4. Number 7. So again, we have decimals. Doesn't change our steps. We follow the exact same steps, exact same rules. Step 1, cut it in half. Step 2, isolate the variable. So here's my variable, a. Remember, a variable can be any letter. It does not have to be x. It does not have to be y. It can be any letter. Okay? So here's my variable a. I want to isolate that and get it by itself. When in order to do that, I'm going to use the inverse or opposite operation. So the opposite of adding 6.5 is subtracting 6.5. What I do to one side, I'm also going to do to the other. Okay. 10.2 minus 6.5. Remember, when you're adding or subtracting decimals, you have to line them up. I can't do 2 minus 5, so I need to borrow, but I can't borrow from the 0. So I'm going to borrow from the 1. That becomes a 10. Now I can borrow from the 10. That becomes a 9. 12 minus 5 is 7. Bring down my decimal. 9 minus 6 is 3. Okay, so I've got 3.7 on this side. My 6.5's cancel. I'm left with a on this side. So I have a equals 3.7. So let's plug it back in and make sure it works. 10.2 equals 6.5 plus, and instead of a, I have 3.7. If I add 6.5 plus 3.7, 7 plus 5 is 12. 6 plus 3 is 9, plus 1 is 10. Bring down my decimal. 10.2. So 10.2 does equal 10.2, so we did that correct. Okay, number 8. This one has fractions. Still does not change our rules. We're going to follow the exact same steps. Okay, this time we're just dealing with fractions, so we're going to have to remember our fraction rules. Step 1, cut it in half. Step 2, isolate the variable. So here's my variable, y. In order to get y by itself, I need to make minus 1/5 go away. So the opposite or inverse operation of subtraction is addition. So instead of subtracting 1/5, I'm going to add 1/5. Okay? And what I do to one side, I'm also going to do to the other. My 1/5 cancel. I'm left with y on this side. Now I have 2/5 plus 1/5. Remember, when you are adding or subtracting fractions, you have to have a common denominator, or the denominator has to be the same. In this case, they are the same, so we don't need to find a common denominator. So we can just do 2/5 plus 1/5. Well, 2/5 plus 1/5 is 3/5. So y equals 3/5. Okay, we're going to go ahead and plug it back in. 3/5 minus 1/5 should equal 2/5. Again, we have a common denominator, so we can just subtract our numerators. 3 minus 1. 3/5 minus 1/5 is 2/5. And that does equal 2/5, so check, we did that right. Last one. 1 equals w plus 1/4. Okay, so step 1, cut it in half. Step 2, isolate the variable. So here's my variable w. I want to get that all by itself or isolate it. In order to do that, I'm going to use the inverse operation. So the opposite of adding 1/4 would be subtracting 1/4. And what I do to one side, I'm also going to do to the other. All right, my 1/4's cancel. I'm left with W on this side. Now over here I have 1 minus 1/4. I'm going to write that over here. Remember, like I said before, when we are adding or subtracting fractions, we have to have a common denominator. Well, this whole number 1 doesn't even have a denominator. So if I have the whole number 1, that is the same as 4/4. So 1 is the same as 4 out of 4. So I'm going to rewrite that, 4/4. So 4/4 minus 1/4, well, that leaves me with 3/4. So 3/4 equals W. Let's plug it back in to make sure. 1 equals 3/4 plus 1/4. Okay, plugging it back in. 3/4 plus 1/4 is 4/4. And we know 4/4 is the same as 1 whole, so yes, we did that right. So these are your notes on solving one-step equations with addition and subtraction.